The question here is, an open box with a square base is to be made out of a given quantity of cardboard whose area is c square units. Show that the maximum volume of the box is c cubed by 6 root 3 units. So area of the cardboard is given to you. From this cardboard, we are going to make a square. We are going to make a cuboidal box, okay, with a square base. Okay, so your cuboidal box is going to look like this. This cuboidal box will have a square base. Okay, square base means length and breadth both are x, and let us consider the height to be h. Okay, and also what is given is that the area of the cardboard is c square units. C square units.
Unit.
We are going to make a box out of this. Okay, so here c is a constant, right? Because the area is given, and I say let the length and breadth of the cuboidal box be x each, and its height be capital H. So here x and h both are variables. X and h both are variables. So what is going to be the area of this cuboidal box? The area of this cuboidal box must be equal to area of the cardboard, right? So, but what is the area of this? And this box has to be made with the. This is an open top box, right? Because when you are making it out of a cardboard, it has to be an open top, right? So area of the base plus area of the four walls must be equal to area of the cardboard. This will give our relation number 1. Area of the base is x square, and area of the four walls is 4hx, because each is a rectangle of area hx, and there are 4 such walls, is equal to area of the cardboard, right? So this will give our relation number 1. Okay. Now what do we need to make? We need to make a box of maximum volume. So what should be the volume of the box? V is equal to length into breadth into height, x into h, which is x square h. Call this number 2. But we need to maximize v. But v has 2 variables, right? X square and x and h. We need to bring this down to a single variable. So with the we'll bring this down to a single variable with the help of 1, right? So from 1, we find out the value of h, because you have x square plus hx. We cannot find out the value of x here because this is a quadratic in x. So we can find out the value of h. putting this value in 2. We get V is equal to x square times c square minus x square divided by 4x. That is, V is equal to 1x will cancel here. So simply going to get x into c square minus x square by 4. For convenience of differentiation, we multiply the entire thing by x. So you get c square x minus x cube divided by 4. This is what you are going to get, the expression for V. Now V is down to a single variable x, right? Now we can differentiate. Therefore, dv dx is equal to 1/4 c square minus 3x square, right? For maximum or minimum volume, we must have dv dx is equal to 0. That means 1/4 c square minus 3x square is equal to 0. That means c square is equal to 3x square. That means x square is equal to c square by 3. That means x is equal to c by root 3. So at x is equal to c by root 3, volume is going to be maximum or minimum. Now we do the second derivative test. Therefore, d2v dx2 ddx of dv dx ddx 1/4 c square minus 3x square. 1/4 is a constant, you take it out. Differentiation of c square is 0 because c is a constant. Minus, and differentiation of 3x square is 6x. Right? So you get minus 6x by 4, which is equal to, cancel here, minus 3x by 2. Now what is the sign? At c is equal to c by root 3, x is equal to c by root 3, d2v dx2 is equal to minus 3 by 2 into c by root 3, which is less than 0. Thus, V has a point of local maxima at x is equal to c by root 3. Okay. Now what is asked here? If you see the question, it is asked, show that the maximum volume of the box is c cube by 6 root 3. So you have got at x is equal to c by root 3, volume is maximum. Now, what is the expression for volume here? If you see, the expression for volume here is this. So what should be the maximum volume? Maximum volume. Let's say V max is equal to, expression is c square x minus x cube by 4. C square x minus x cube by 4. Now, if we simplify this, we are going to get, that is c cube by root 3 minus c cube by root 3 cube is 3 root 3 divided by 4. Now you take the LCM, you get 3c cube minus c cube divided by 3 root 3 divided by 4, which is equal to 2c cube divided by 3 root 3 whole divided by 4, which is 2c cube divided by 3 root 3 into 4. Now you can cancel this. You get c cube by 6 root 3. And that is what was asked. Maximum volume, I think. Yes, c cube by 6 root 3. Hence the proof. So this was an easy one. Any question here? At any step?
No, sir.
Okay, now the next question. The question here is the sum of the surface area of a rectangular parallelopiped. What is a parallelopiped? You can consider it to be a cuboid, a long cuboid, okay, like a pipe, a cuboidal pipe, you know, with sides x, 2x, and x by 3. Okay. And a sphere is given to be constant. The sum of the surface areas of this rectangular parallelepiped and a sphere is given to be constant. Okay, prove that their volumes is maximum. That is, their volume means sum of their volumes is maximum if x is equal to 3 times the radius of the sphere. Find the minimum value of the sum of the volumes. Okay. So you need to show that the volume is sum of the volumes is minimum when x is 3 times the radius of the sphere. Also, you have to find out the minimum volume. Okay. So because their sum of surface areas is given to be constant, I start by saying let the radius of the sphere be, say, let's say small r. So here r is a variable. Okay, so what should be the surface area of the sphere? Surface area of the sphere formula is 4 pi r square, right? Now, what should be the surface area of the rectangular parallelepiped? What is the surface area of a cuboid? Class 9 knowledge. You remember? Twice LB plus BH plus LH, right? What are the sides given here? Length 2x, length x, breadth 2x. Breadth 2x, height is x by 3
Expect.
plus length x and height x by 3. This is your surface area. Okay, so you get here twice 2x square plus 2x square by 3 plus x square by 3, which is equal to twice 6x square plus 2x square plus x square by 3, which is equal to twice 9x square by 3. So you can cancel this 3 and 9. So simply get 6x square. So what is given here? That the surface area of the sphere and the surface area of the rectangular parallelepiped is given to be constant. So therefore, surface area of the sphere here is 4 pi r square plus surface area of the rectangular parallelepiped is 6x square is equal to constant. right? Let us call this equation number 1, right? Now, what are we to do here? We need to find the sum. We need to minimize the sum of the volume of the rectangular parallel pipe and the sphere. So, what is the sum of the volumes? Let's say V is equal to 4/3 pi r cube plus 6x square plus x length into breadth into height into 2x into x by 3. Yes,
Yes, sir.
that means V is equal to 4/3 pi r cube plus 2x cube by 3. This is the sum of the volumes. Call this equation number 2. Now the problem is we need to minimize V, but with the help of 1, can you bring this down to a single variable? That is my question to you. Is it possible? Can you tell me? Is it possible or not? Just look at these two relations and tell me.
Which two? Like one
One,
and two.
1 and 2. With the help of 1, can we bring down 2 to a single variable?
Yes, sir. We can
How?
substitute it.
Yes, we can substitute, but you see
But
the powers
but
are
K will
square.
be constant again.
Which one?
But yes, sir, the power square is there, so it will come complicated.
Yes, that is what I'm talking about. That will come to a power of 3 by 2, right? You'll get a square root and then you will have to cube that square root, isn't it? So in order to deal with this,
Mm.
what we do here is that we, instead of bringing 2 down to a single variable, whenever it is difficult to bring down, the maximizing or the minimizing function to a single variable, what we do here is we differentiate 1. So from 1, 4 pi r square plus 6x square is equal to k, right? Now from here, we are going to differentiate both sides of this with respect to x. Or you can do it with respect to r also, no problem. If you are doing it with respect to x, you will get dr dx. If you are doing it with respect to x, you will get dx dr. Okay. You can do it either way. Let us differentiate with respect to x, differentiating both sides with respect to x. We get 4 pi is a constant into 2r dr dx, because r is a variable, right? Differentiation of implicit functions, plus 6 into 2x is equal to 0. From here, we shall find out the value of dr dx. That means you get 8 pi r dr dx plus 12x is equal to 0. That means you'll get 4. You can take common. You'll get pi r dr dx plus 3x is equal to 0. This should be 2 pi r because there's an 8 here. Okay. So that means 2 pi r dr dx plus 3x is equal to 0. That means you get dr dx is equal to minus 3x by 2 pi r. Call this number 3. With the help of, because it was difficult to bring down v to a single variable, we had differentiated 1 and found out dr dx. Call this 3. Okay. Now you do the same with 2. So from 2, v is equal to 4/3 pi r cube plus 2x cube by 3. Okay, differentiating both sides. because we have differentiated 1 with respect to x, we differentiate 2 also with respect to x. With respect to x, we get dv dx is equal to 4/3 pi into 3r square dr dx, right? Plus 2/3 into 3x square, right? We can do this.
Mm,
You can cancel these 3's here.
yes.
So you get 4 pi r square. And what is dr dx from 3? Minus 3x by 2 pi r plus 2x square, right? So what do we get here? This will cancel here. Pi and pi will cancel. So what are we getting here? We are getting, and 1 r will also go, right? So we're getting minus 6xr plus 2x square, right? Now we have got an expression for dv dx. So for maximum or minimum volume, maximum or minimum v, we have dv dx is equal to 0. That means minus 6xr plus 2x square is equal to 0. Now I can take 2x common to get x minus 3r is equal to 0. That means either x is equal to 0 or x minus 3r is equal to 0. But x not equal to 0, right? X cannot be equal to 0. Therefore, x must be equal to 3r. Right? Now we have got a relation between x and r. Right? So for maximum and minimum volume, x must be equal to 3r. So now whether it is maximum or minimum, we find out with the help of second derivative test. Right? So we differentiate once again d2v dx2. Therefore, d2v dx2 is equal to ddx of dv dx. Is equal to ddx of, now what is dv dx here? We have found out above. dv dx was minus 6xr plus 2x square. Minus 6xr plus 2x square, which is minus 6r plus 2 into 2x. Oh, 6x dr dx, because r is a variable, right? Let's not forget that. So minus 6 into you differentiate this xr by u into v rule. So you get r plus x dr dx, right? Plus 4x,
4 प्रकार में
right? Which is equal to minus 6 into okay, we have got this, right? So at x is equal to 3r, what is the sign of d2v dx2? Minus 6. Okay, r you write as it is. What is dr dx we have got here above from 3? Minus 3x by 2. Okay, so we bring everything in terms of r. R plus 3r. How much is dr dx? Minus 3x by 2 pi r. Right? And plus 4 into 3r. So now what happens? Anything that cancels? Yes, this R and this R will cancel. Okay, and still X is still remaining here. So we can put X is equal to 3R after this. R minus 9x by 2 pi plus 12R. Okay, this is so minus 6. R plus 12R will give you 13R minus 9 by 2 pi and X is equal to 3R. Right? Minus 6, 13R minus 18R by 2 pi. 27, not 18. Right? Now what is 13R minus 27R R by pi? Is it positive or is this negative? Can you tell me? 27R by 2 pi. Is it positive or negative? This entire
Positive, because
expression.
my
Why positive? Why positive?
27R by 2 pi. No? Because
Yes, 20.
outside
No, no, I'm
minus is
talking about the
already
entire
there.
expression. This is minus 6 is negative. So 13R minus
Yes, sir.
27R by 2 pi. Is it positive or negative?
Then the whole thing is negative,
Minus 6,
I
13R
think.
minus, you put the approximate value of pi, 2 into, let's say 22 by 7. Minus 6 times 13R minus 27 into 7 is how much? 189. R by 44. Right? So this is yes, this is positive, right? So this volume is should be minimum. So this should come to be positive. Just wait a minute. Now you see that d2v dx2 at x is equal to 3r. You have minus 6 and you have r plus x is equal to 3r. And at x is equal to 3r, what is the value of dr dx? R is equal to x by 3, right? So what is dr dx? It should be 1/3, isn't it? Yes?
Yes, sir.
Plus 4 into 3r. So now this and this will cancel. So you're going to get minus 6 and you have r plus 12r, which is equal to minus 6 into 14r, which is obviously less than 0. Thus V has a, you can write it here. I'll just to state the point. Since x is equal to 3r implies r is equal to x by 3, which means dr dx is equal to 1/3. Okay. Thus V has a point of local minima at x is equal to 3r. And what was the question? Yes, prove that the sum of the volumes of minimum if x is equal to 3 times the radius of the sphere. So we have proved the first part. That is x is equal to 3 times r. We have proved the first part. Also, we need to find the minimum volume. Also, V min is equal to, what was the expression for V? Expression number 2, equation number 2, in fact, this one. You put the value of X here. It was 4/3 pi r cube plus 2x cube by 3. Two-third x cube. X we have got as 3r. Okay. So what is the minimum volume? 4/3 pi r cube plus 2/3 into 27 r cube. So you get 4/3 pi r cube plus 18 r cube only, right? Yes, 18 r cube. Fine. So which is equal to, take the LCM now, you will get 4 pi r cube plus 54 r cube divided by 3. That means 2/3 r cube into 27 plus 2 pi. This is the minimum volume. Clear? Now this problem was a little different from all the other problems, because here, if you see, we were not able to find this 2 in terms of a single variable, right? So what we did was we differentiated this also and found out dr dx from here, and this value of dr dx, when we differentiated this, we put it here. Yeah, you can do this in fact for all the problems, but because you are not acquainted with this method, so that is why I not do. In fact, this method will make a lot of problems easier. Okay. Anyway, you do the way that it's given in the textbook and is given the way I have taught you. Okay. So I'll stop here then.